Section 4.9 Characteristic Structures of Ionic Solids. I'd like you to watch this video. Over here it's about 11 minutes. You will see different three-dimensional crystalline structures of various ionic solids. This is a more complete table of different crystal structures. For example, rock salt structure is adopted by sodium chloride, potassium bromide, etc., etc. So all those ionic compounds have similar rock salt structure, with each cation surrounded by 6 anions, and each anion surrounded by 6 cations. All right, and this is also a very common crystal structure. For example, cesium chloride. Each cesium is surrounded by 8 chloride. Each chloride is surrounded by 8 cesium ions. So again, I want you to watch this video to really see the three-dimensional structures of different ionic compounds and different types of crystal structures. Now let's look at sodium chloride. Again, it's called rock salt. And each chlorine minus is surrounded by 1, 2, 3, 4, 5, 6. 6 sodium plus. Alright? And each sodium plus is surrounded by 6 chlorine minus. 1, 2, 3, 4, 5, and there's another one. Okay? Perpendicular to the screen, you should be able to imagine there's another one here, opposite to this one. Alright? And then over here, this is just the two-dimensional projection. Now let's look at the coordinates here. It says 0, 1. That means there are 2 layers. The color is purple, so that's sodium plus. You have 2 sodium plus ions. So 0 and 1 are this guy and this guy. And then you have a green one with a height of half C. So that's this chlorine minus. And over here you have the purple half. That's the purple half. You have green 0, 1. That means 0C and 1C as the height of the green anions. So this is 0C, and this is 1C, and this is half C. Again, over here you can see, well, 0, 1, that's purple. 0, that's sodium plus, 0C, 1C, and half C, that's chlorine in the middle. All right. This is a more complicated ionic structure with polyatomic anions. So over here you have C2, 2 minus as the anion. But if you compare this structure with the previous sodium chloride, okay, they are exactly the same. Again, each anion, this is one anion, is surrounded by 1, 2, 3, 4, 5, 6 cations. And each cation is surrounded by 1, 2, 3, 4, 5, and another one on the opposite side to this one, 6 cations. So this sodium chloride structure and this calcium C2 structure, they are both rock salt structure. Now this one is different. This is cesium chloride structure, and now you can see each anion is surrounded by 8 cations. And we know the formula is cesium chloride. If one chloride is surrounded by 8 cesium plus, then each cesium plus is also surrounded by 8 chlorine minus. So how about this one? This one is surrounded by 1, and then you have to imagine 7 other chlorine minus. So I think if you do a translation, there should be 1 here. All right, there should be 1 here. And then 1 here, 1 here. That's 4 of them. And then you have to imagine we have 4 more away from, closer to you, away from the screen. So a total of 8 chlorine minus anions surround this cesium plus. Now this is a two-dimensional projection. Again, if you look at this, it's labeled by 0 and 1. That means you have 2 atoms in 2 different layers with 2 different height, 0C and 1C, so 0C and 1C. All right, so this green is this green with a height of half C, so this one is just half C from the bottom. This is another different structure. If you look at the sulfide, the green ones, it's face-centered cubic. So this is face-centered cubic. This zinc 2 plus simply occupy the space, unused space, inside 1, 2, 3, 4, inside this tetrahedron. Okay, 1, 2, 3, 4. This 4 sulfide form a tetrahedron structure, and in the center of the tetrahedron there is unused space occupied by this zinc 2 plus. Okay, same here, 1, 2, 3, 4. This 2 sulfide can form a tetrahedron structure, and then this zinc 2 plus occupies its center. Same here, same here. This one is surrounded by 1, 2, 3, 4 sulfide ions. And this is zinc sulfide. So actually, if each zinc is surrounded by 4 sulfur, then each sulfur should be surrounded by 4 zinc. This sulfide is surrounded by 1, 2 zinc ions from the bottom, and you have to imagine there are 2 more on top. So this sulfide is also surrounded by 4 zinc 2 plus. The coordination number for the sulfide is 4. The coordination number for each zinc 2 plus is also 4. Now this is the 2-dimensional projection over here, and now we have to look at this too. If you look at this too, they have a height of a quarter C, and this one a quarter C. All right, so along this diagonal, so a quarter C, a quarter C. And now this two has a height of 3/4 of C. So 3/4 of C and 3/4 of C. So these 4 lattice points are zinc 2 plus. Now let's look at sulfur. We have many sulfur, but if we look at these 2 sulfur sulfide anions, so they are here, 0 C and 1 C over here. All right. And then you can look at the middle one. Okay, you have 0 C, you have 1 C. Another structure, this is calcium fluoride, and the formula is calcium 1 fluoride 2. All right, so you can see actually in this case, since each fluoride is bonded with 1, 2, so this fluoride is bonded to 1, 2, 3, 4 for calcium, then each calcium is supposed to be bonded with 8 fluoride. So 1, 2, 3, 4, and then you have to imagine 1, 2, 3, 4. On top of this face, there are 3 green spheres bonded to this purple calcium 2 plus. All right, because again, the number of bonds, the ratio of the numbers of bonds is equal to the ratio of the number of ions. All right, and then similarly we can draw the 2-dimensional projection here, but in this case, if you look at this fluorine minus, there are 2 different heights now, because you have a fluorine minus here, another fluorine minus on top of this one. All right, so if you again, this is the top view. If you look at this 3-dimensional crystalline structure from the top, you have this one sitting on top of this one, and they have different heights, 1/4 versus 3/4 of C. C is this sideways, this is C. All right, and then if you look at calcium here, 1/2 of C, so it's here. 0, 1 means you have 2 layers, 0 C versus 1 C. All right.